Welcome to our Unit 1 review video. This video is going to take you through the key concepts and ideas from Unit 1 that you need to be prepared to demonstrate on our upcoming quiz, test, exam, assessment, whatever word you want to use for that. So without further ado, I want to talk about what is and is not the role of the review. So this is our first quiz test for the year, and it's a good time to really establish what is the role of doing review. Well, what is it? To go over the main ideas and skills needed for the test, because sometimes when you're coming up on a test, it's been a few weeks since you've done some of your older skills. So we need to go over those, refresh them, make sure we still remember what they are. To provide you with some example problems that will give you an idea of what to expect. So we want to be a little bit more specific. There is a little bit more support provided there. And to identify areas for further review and study. So one of the things the review can do is it can point out to you that, ooh, this is an area that is weak, or I was absent on this day and I need to make sure I go back and review that a little bit more. What the review is not. It is not a replacement for doing the actual lessons and assignments. So there's no situation where you can only watch the review and make up for the fact that maybe you haven't come to class or you haven't done any work and you don't have any notes or anything like that. If you've made some poor choices along the way in the unit, the review cannot fix that for you. It's also not a question for question model of the actual test. So sometimes what can happen with reviews and with study guides is they become this like kind of essentially a model test. And if you can mimic or memorize what was on that test or on the review, then that's exactly what you're going to see on your exam. And that's not really showing me what you can do on your own. So this is not a question for question. This is exactly what you're going to see. But it is going to give you a pretty good idea of what you'll see. So how does this review work? Watch this video with the volume on. Now, clearly this has been an issue because I have put it in this presentation with capital letters because there is a tendency to sometimes watch videos with the volume off, and that does not work as well. I'm not going to say it's not beneficial at all to see some of the problems worked out, but there is a verbal or auditory explanation that comes with the work that you're about to see, and it is something that you want to attend to. So you should not have headphones on, you should not have other music playing in the background, that sort of thing, while you're also trying to listen and attend to this material. That's just not how our brains work. So you want to watch the video with the volume on, like paying attention to the video. Take notes. Okay, so when there are example problems, pause the video or practice. These are more example than practice, I guess. So take notes, work out the example problems with me, maybe pause the video, work the example problem out ahead, and then watch that to kind of see how you're doing. And then copy down any key ideas that you need to refresh. So if I put something on the screen that is a key thing, you write that down, because that writing it down is going to reinforce that for you and help you remember it come test day. And then go back to your actual class notes for further example and review as needed. There's nothing in the review that's going to have as much detail as your original class notes that go like unit or lesson by lesson with the examples that came with that lesson and the key ideas that came from that lesson. So that's really your main bank. Now, if you're listening to this and thinking, I don't know where my class notes are, or I didn't take notes, or I was absent and I never watched the lesson video to get those notes, that is potentially problematic for you. So if you're watching this review video with enough time to also watch those videos, which I understand is a lot of video watching, but if you haven't done it, like I said, this review is not going to make up for that. So make sure that you have your class notes and you have your examples. I recommend hanging on to all your class notes at least until the end of the 9-week period, okay? Potentially also the end of the semester, but I don't necessarily expect you to have them in class with you if they're like really old, but you want to hang on to them. And then lastly, notify me about concepts or questions from this review that you would like to go over again in class. So use this review to springboard questions that you have for me. I don't expect you to remember everything. I do expect my students to come to the review with some questions, like, can you explain that again? Or can we see another example of this? Or you did this in the lesson, but it wasn't in the review. Can we look at that? So let's begin with lesson 1. So what do you need to know from lesson 1? You need to know the definition of the solution to an equation. And I'm not going to give that to you in this review video because, like I said, I want you to do some of the legwork yourself to prepare for this test. So look this up in your notes and write it down. If you are realizing I don't have notes, everything should be posted online. Now, the year that I'm recording this, I am recording this on May 24th, which is the end of the school year. I was using OneNote. Sometimes that changes, okay? Sometimes the district adopts a new platform. But somewhere there is a video posted and there are potentially like notes, a copy of the PowerPoint, that sort of thing. Go and find it if you don't have it. Know what the definition of solution is, look it up in your notes, and actually physically write it down on a piece of paper. Be able to use the definition of solution to identify solutions of equations. Okay, so the first skill here is, now that you know the definition, you need to be able to use the definition to identify solutions. So identify solutions means that you were given a possible solution and you are asked to identify, like, is this or is this not a solution? So this can include equations that are not linear. So while this intro unit focuses on reviewing lines, I really want to emphasize the key ideas stretch beyond linear equations. So our content in Algebra 2 is not like isolated little chunks of knowledge that have nothing to do with each other. Once you know the definition of a solution, you can expand that and apply it to things that are beyond the unit that we're in. So here's an example. Is x equals 0 a solution to -4 plus 3 cosine x equals -1? Now, we don't even touch trigonometry in this class, okay? But you do have a calculator. In fact, you have Desmos, okay? So you can pull up Desmos, or you can pull up some other calculator. And what you would do is you would take x is equal to 0 and plug that in for the x. So this would be -4 plus 3 cosine 0. And the thing about definitions is that you don't need to know what cosine is. That doesn't change what it means for something to be a solution. So what I would do at this point is I would simply dump that entire expression into a calculator. -4 plus 3 cosine 0. Even though you don't know what cosine 0 is, you can still do that. And you will indeed get -1 is equal to -1, which is a true statement. And so your answer to the question would be yes. So even though that is not a kind of equation that you have ever solved, what it means for something to be a definition, to be a solution to an equation, that still doesn't change. So I'm not going to give you something that's going to require a skill that you don't have, but you all have the skill of, I can type that into a calculator. So it could be something that's not linear. I will put your mind at ease a little bit. It's not going to be trig because you might not know where the trig buttons are or where to, like, how to use them. It will be something that we've done in the lesson. I just wanted to illustrate what we mean by that. Now, be familiar with the process for solving linear equations. If there's any step in the process that tends to trip you up, write it down to go over again in class. So I'm going to go through the process for solving linear equations. There's flexibility here, but I try to be pretty consistent with it. If there is distribution to do the distribution. Okay, not every linear equation has distribution, but if there is some distribution, go ahead and get that done. Combine like terms, and then that specifically combine like terms on each side separately. When I say each side, what I mean is each side of the equal sign. So you look at the left side of the equal sign and you see, is there something that I can combine? Do I have like a 2x plus a 4x? Do I have some numbers I can combine? And then you look at the right-hand side and you see if you can do that on the right-hand side. Get the variable on one side. This involves either adding or subtracting some of the variables to each side if you've done the first two steps. So you're either going to like say add 2x to both sides or subtract 2x. Now, not all equations have the variable on both sides, so maybe you're looking at it and saying, oh, well, the variable is only on one side. Well, then you're good to go with that. And then solve the resulting 1 or 2 step equation. There are other ways to navigate this, but if you do the steps in this order, then you'll always land at either a 1 or 2 step equation, depending on how some of the numbers work out, and then you can take it from there. So here's an example. Be able to solve linear equations. So you are actually going to be given some linear equations and asked to solve them. Remember, solving them means that you're looking for the value of the variables that make the equation true. So for this one, we would distribute. Now, here's a little bit of a tricky part. You are distributing a -2. So what you're doing there is you're actually distributing a -2, which means that when you go to multiply, you will have -2x, and then -2 plus times 5 is -10. Many, many, many times students will ask me, where did the plus sign go? Well, we distributed the negative along with the 2. Second step is to combine like terms. And if I look on the right side of the equation here, there are no like terms to combine. So -4x and 7 are not like terms. But over here on the left, I have 3 minus 10. And so I can do that piece of it. So I could do 3 minus 10, which is -7. And it doesn't matter which side you write the -7 on. So I'm going to write it on the right side here. So next step is to get all the variables on one side. So you can collect them on either the left or the right. I like to collect them. Well, I actually like to keep them positive. So in this case, I can undo a -4x by like adding 4x to both sides, and make sure that you do line that up if you are showing that step. -2x plus 4x is 2x, and -4x plus 4x right here, -4x plus 4x is 0. That's why it cancels out. Okay, so make sure you're doing the right operation there. And then from here on out, we just solve the resulting 2-step equation. So I would add 7 to get 2x is equal to 14, and then divide by 2, and I land at x is equal to 7. Now, if you need to, pause the video, like write that down, and give your brain a moment to process it. Okay, I did do it kind of fast. Sometimes I go into autopilot. Now, sorry about that. That's like called spacing when I have the animations running. Note, go back to this lesson and take a look at the variety of linear equations we covered. This problem is a sample and may not look may not look at all facets of the, no, that is a sample that may, I think there's another word behind there, this problem is a sample that may not look at all facets of this problem type, meaning that there might be some variations on this particular problem type that this does not cover. And so you might want to go back and look at the lesson and just kind of scan through some of the examples in the lesson. Lesson 2, I apparently did not enable animations on this. So, know the definition of a graph, and same with know the definition of a solution. Go and look that up in your notes, okay? That is one of the key ideas and primary things from lesson 2. It's probably one of the first things in the lesson, so you don't even need to watch the video very long. But know what a graph is. Similar to lesson 1, be able to identify whether a point is on a graph. This will include equations that are not linear. So for example, is 236 on the graph of y equals 2 times 3 to the x? And this is done very much the same way the other problem was. You've got x, and x is equal to 2. And you've got your y, and your y is equal to 36. So we go ahead and plug those in. And remember your order of operations. So a common mistake on this is to do the multiplication and to say, oh, 2 times 3 is 6 and 6 squared is 36. It's true, it's on the graph, but that is not your order of operations. Your order of operations is parentheses, then exponents, then multiplication and division. So we need to do that exponent first. 3 squared is 9, and I got 36 is equal to 18, which is false. And so my answer is no. That point is not on the graph. So that was a 2-for-1. We reviewed some order of operations, and we also reviewed the concept of identifying whether or not a point is on a graph. Next skill, be able to generate a table to graph a line. This may include tables where X is not provided for you. So I'll try to make sure that this is scaffolded. The test is partially written at the time that I'm recording this. So I'll try to scaffold that so that if I am allowing you to pick your own X values, that I am reasonably sure like there aren't any like really awful X values that you might pick. If it's a line, yeah, it should be fine. So you would set up your table, and then you want to pick some values for X. Well, I'm a big fan of X is equal to 0. And you will not have to show this scratch work, so I will permit you to do this on a calculator. So we have 2 times 0 is 0, so essentially we end up with 3y is equal to 6, which means that y is equal to 2. And let's try X is equal to 1. Okay, so plus 3y is equal to 6. 2 times 1 is 2. And then we would subtract the 2. And so we end up with 3y is equal to 4. And divide both sides by 3. And y is equal to 4/3 or 1.33333. Okay, not really thrilled with that. Let's try X is equal to, I guess let's do X is equal to 2. So 2 times 2 plus 3y is equal to 6. So 4 plus 3y equals 6. Subtract 4. So 3y is equal to 2, and divide by 3, and I get y is equal to 2/3. Also not thrilled with that. That is 0.66666 repeating. And let's do one more point. Let's do X is equal to 3. 2 times 3 plus 3y. Oh, I think I like this one better. So this is 6 plus 3y. When you subtract 6 from both sides, you get 3y is equal to 0, which means that y has to be 0 because 3 times 0 would give you 0. Once you construct your table, and again, you do not need to show me all this work, okay? You will be, now, if you do show it, that's fine, but you will have access to a calculator to be able to do that. So I just wanted to make sure that we knew where all those values were coming from. And you'll notice that I picked some values that were good and some values that were not so great. Those do not want to leave. And then you will be provided with a coordinate plane. And 1, 1, 2, 3, and okay, and then we'll go ahead and put our points on there. So I'm going to actually start with the point 0, 2 because that's an easy one. And then I have down here the point 3, 0. Now, technically, that's enough for me to get the line, but the other 2 points should be on the same line. So if I go over 1 and then up 1 1/3, I am estimating that, but it would be right about there. And if I go over 2, I would go up about 2/3 of the way, which would be right about there. And you can tell that even though those are yucky points, they are actually on the line. Do make sure that you graph the line itself and don't just plot the points. I remember that being an issue a couple years ago where students would just plot all these lovely points and they didn't actually graph the line. Okay. So that's what we mean by generate a table and plot some points to come up with the graph. The value of that isn't that it's efficient. It's actually not efficient at all. But it really emphasizes the connection between the 3 ways that we display functions. You have your equation, you have your table, and you have your graph. And so you can see the 3 different representations in one problem. Be able to sketch the graph of a new equation by generating a table and plotting points. So that would be something that's not a line. For this skill, you will be provided with possible x values. So if it's something that's not familiar, then I'm not going to leave you high and dry and just like, hey, pick some numbers and they might be terrible numbers. Like I will provide you with some guidance there. So for example, sketch the graph of 3 times the square root of x minus 2, and you would be provided with that table, and you would simply plug in those numbers. So we can kind of do this in our heads maybe. So if x is equal to 0, the square root of 0 is 0. 3 times 0 is 0, and 0 minus 2 is negative 2. Next one, x is equal to 1. The square root of 1 is 1. 3 times 1 is 3, and 3 minus 2 is 1. Next one, x is equal to 4. The square root of 4 is 2. 3 times 2 is 6, and 6 minus 2 is 4. Next one is 9. So we have the square root of x is equal to 9. The square root of 9 is 3. 3 times 3 is 9, and 9 minus 2 is 7. And last but not least, 16. X is equal to 16. The square root of 16 is 4. 3 times 4 is 12, and 12 minus 2 is 10. And again, you will be able to use a calculator to do that, so don't freak out. Like I'm not going to try to trip you up with stuff we haven't covered. So you just plug it in, and then you will be provided with a coordinate plane. And all you need to do is plot those points and then connect them as best you can. So we have negative 2, 0, negative 2, 1, 1, 4, 4, 9, 7, is right there, and 16. Good luck with that. This is what, 10, 11, 12, 13, 14, 15, 16, and we're going up to the 10. I might have drifted over one there. And so when you go to connect them, they go like that-ish. Okay, and I'll be lenient if it's something that you're not familiar with, so I don't want you to stress out over that. Sorry, that I did not do that very well, but that's the skill. And again, this is about knowing what it means to generate a graph. It means knowing like a skill that transfers outside of linear, because some of the things we graph are going to be very simple to graph. Other things are much more complicated, and a lot of times this comes in handy on a multiple choice question. So again, we have the connection between the equation, the table, and the graph. From lesson 3, be familiar with the different ways we talk about and calculate slope. Look these up in your notes. Okay, so we had a definition of slope as the measure of steepness. We had rise over run. We had delta y over delta x. We had rate of change. Okay, so we had different ways. It was on a slide. I can see it in my head. Next skill, be able to find the slope of a line from a graph, both with and without the dots provided. So sometimes on a graph, people will provide you with the dots. It kind of guides your eye to, hey, use this point right here. But like a graph doesn't have to have dots on it. So if there aren't any dots on it, this is what you are to do. So this graph has no dots. So follow along as I'm tracing. What I'm looking for is something that I can be very confident is a point on the line. So see right there, like my laser pointer is on top of it, but right there, -5, +4. I am really, really sure that that's a point on the line. As I come down here, I see another one, -3, +3. Okay, right there. Right here looks really good, 0, +2. Okay, as I keep going, I've got the point 3, 1. Looks like a good point. And then I have this one here, 6, 0. Also looks really good. Now, you only need 2 of those to find the slope. So just pick any 2 points. So I'm going to go with those first 2 that I saw. Okay, and essentially what I'm doing is I'm putting my own dots on there. Like, I think these are good points. And then we're going to count the rise over the run to get from one point to the other. So I would go down 1. Okay, so here's my rise. My rise is down 1 over the run. And that's going to be 1, 2, 3. And so the slope of that line is negative 1/3. If you get a fraction that can be simplified, please simplify it. And some of them I might give you the dots, and so I'll tell you where to look on the graph. But if you're not given the dots, you just go and look at it and find some nice points. Don't use a point like this one, because I don't know where that point is. Okay, so we want to go find points that have nice numbers. Be able to calculate slope using the formula, and so that means you do need to know the formula. But if you don't know the formula, you would simply use the fact that slope is the rise over the run, or the difference in the y's over the difference in the x's. And you can label these any way you want. So I'll make this x1, y1, and we'll make this one x2, y2. You can do it the other way around if you want. So y2 is negative 15 minus y1, which is 4, over x2, which is 10, minus x1, which is negative 3. This will be negative 19, and this is 10 plus 3, which is 13. Simplify your ratio if you can, and you can also use Desmos to do that. So there's your slope, okay? It's kind of a yucky slope, but there it is. That's what happens when your teacher just makes up some numbers. Be careful about the subtraction, okay? You always have a subtraction that comes from the formula right there, but sometimes you will also get another negative that will come in on the number, and that's how sometimes you can end up with that double negative, which is adding. Now, the next skill for this is be able to write the equation of a line given 2 points. So we used for this point slope form, which I believe I gave to you this way. I remember texting one of the other teachers and said, hey, what way is best for that? So I think that's the way I gave it to you. And so all you would need to do is this. Plug in your slope and then pick one of those 2 numbers. So we would do x, I'm going to do x minus negative 3 plus 4. And because I don't really like minus a negative, I'm just going to go ahead and write plus. Or you could use the other point. Okay, so you could have y is equal to negative 19 over 13 times x minus 10 and then minus 15. And that is all you need to do. What I would recommend, those 19s don't really look like 19s. We can do a little bit better. I don't know why I was doing that with my mouse instead of my finger on the touchscreen. Can't explain myself. So I would not do both if it were me, because if you give me both of them and one of them is wrong, you're kind of forcing me to take off something. It's not like I'm going to just say, oh, give me all these answers and I'll just take whatever's right. Like it can't quite work that way. So yeah, I do need to consider all that you've put down as a potential answer. So, but if you do both of them and you're like, ooh, that one was much easier, I didn't have a double negative, and you want to erase one of them, that's fine. All right. Know how to determine the slope and graph that's awkwardly phrased, horizontal and vertical lines. So some of that you do need to go back into your notebook to take a look at. But for example, let's find the slope of that line right there. So you could actually do that two different ways. Let's actually skip to this. What would the graph of this line look like? Well, go ahead and graph it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 1, 2, 3, 4, 5, and 1, 2. And the points on that, if I go and plot them, 9, -2 is right there, and 9, 5 is right there, right above it. And so there's your graph. Okay, and so the answer to that is this is the graph of a vertical line. Now, there are two different ways that you could come up with the slope. One, you might remember that the slope of a vertical line is undefined. However, you could also use the formula. So this might be -2 minus 5 over 9 minus 9, which is -7 over 0. And remember, we cannot divide by 0. So this is undefined. It is not actually a function. But you might remember that the slope of a vertical line is undefined. So you can come up with that a couple different ways. And you would also need to be able to navigate horizontal lines. So this review is covering vertical lines, but you on your own might need to do horizontal lines. Okay, and then if you still need further review, that's the kind of thing you go ahead and you notify Ms. Taylor about and say, I would like to go over horizontal and vertical lines. Here's what I did. Next bullet point, know the relationship between the slope of a line and its tilt. So match the line with its graph. So the slope is this number right there. And we know that a positive slope should tilt up and a negative slope tilts down. And I intentionally took all the numbers off of that so you don't actually know where the y-intercept is or exactly what the slope is. You are having to go by the tilt of the line alone, and that is your key concept with that, that we understand the tilt of the line and the slope there. Now, this is an interesting one. Given a curve, be able to find the slope between different pairs of provided points. Know how this concept relates to the slope of lines. See the key idea from this lesson. And to find the slope between the red points, then find the slope between the blue points and how do they compare. So I'll do the red points in red, and the red points appear to be at 0, -4, and 1, -2. So for the red one, we might do -4 minus -2 over 0 minus 1. I don't know why I did it that way. That is -4 plus 2 over -1. -4 plus 2 is -2 over -1, and a negative divided by a negative is a positive. So the slope there is 2. If I were to kind of connect those, it's like finding the slope of that line there that goes through those 2 points. So the slope would be 2. On the blue, it appears that those points are 2, 4, and 3, 22. And so finding the slope between those points, I'm going to do this the easiest way I can. 22 minus 4 over 3 minus 2. 22 minus 4 is 18 over 1, which is 18. And that would be as though you were finding the slope of that line. Okay, or something close to it that like was moved over a little bit. And what I want you to get from that is that the blue slope is much steeper than the red slope. So we could say like blue slope is greater, comma, or semicolon, line is steeper. Okay, or you could say like the red slope is not as steep, or the red slope is smaller because it's only a 2 as opposed to an 18. So what we want to get at there is the idea that on that curve, the slope is changing. The slope is not the same everywhere. So down where the red points are, it's actually not very steep. Where the blue points are, the graph is much, much steeper. How does that relate to the slope of lines? Well, lines are the same slope everywhere. And so that was our key idea. I just saved you the trouble of looking it up in the lesson. But in a line, if you were to take the points from any location on the line, you would get the same slope every time. Now, hopefully this makes some pretty good sense to you. This comes back later in math. Okay, it comes back not in algebra 2 a whole lot, but we want to lay the foundation for this particular idea that the slope is actually changing. Lesson 4. Know the definition of a function. Look this up in your notes and write it down. Okay, go and look it up. Okay, so Ms. Taylor is providing you with the information that you need to know for the test, but it is up to you, the student, to go and find that information. So I'm telling you, you need to know the definition. Look it up in your notes, write it down. Be able to determine whether a relation is a function from both a set of ordered pairs and from a graph. There are lots of examples of this in the lesson, okay? So yeah, I would strongly recommend going back to your lesson 4 notes or going back to the lesson 4 video, because we did tons and tons of examples of this in the lesson. Like, is this a function? Is this not a function? You know, what does the ordered pairs and the mapping, like what do all those things look like? So this one is the graph below a function? And so this is from the graph. And I know there's a gray dot looking over it, but if you look at the vertical line test, okay, we can see that this vertical line crosses the function at more than one spot. So we could say no, and the reason is that it fails the vertical line test. Okay, it fails the vertical line test, does not pass it. We've got ordered pairs that are on the graph that are stacked over each other, and that is a no-no. Okay, we do not have ordered pairs that are stacked over each other. All right, be able to identify and or describe the parts of function notation. So that gets into the special notation that we use for functions. So we don't actually use y all the time. We do use the notation f of x, which I have here as h of t. And the question here is, what part of this is the name of the function? And in this case, the name of the function is h, which might stand for, say, height. Okay, and then the t is the variable, or it's the input. It's like the set that you're mapping from. And so usually when you see a t, that does represent time. Not all the time, but usually it does. So you could be asked, what is the variable, or what is the input to the function? The input of the function would be t, and then the output of the function would be h. And one of the reasons that I do tell you to watch this video with the sound up is because I'm not going to write that down. So somebody listening to this on mute is going to write down this, and they're going to swear to me that they watched the video, and they're going to miss the whole part of this on, like, the input is t and the output is h, and that's a different way that you could ask that question. Be able to evaluate functions. The word evaluate in math typically means find out what number this is equal to. This includes functions that are not linear, because this particular skill of evaluating functions has to do with whether you understand function notation and whether you know order of operations. It does not have to do with, like, knowing how those functions behave or anything. So, for example, if f of x is equal to 10 over x plus 2, find f of 3, show all work. So this is a rational function. We have not studied rational functions. That's actually Unit 7. However, you don't need to know what kind of function this is, because what you need to know to answer this question is what is function notation and order of operations. So what we would do for this one is we would plug in f of 3, which means to plug in a 3 everywhere there is an x, and then you would carry on order of operations. So 3 plus 2 is 5, and 10 divided by 5 is 2. So f of 3 is equal to 2. And that's all you need to do to evaluate a function. That is not multiplication. It is not f times 3. So please do not try to divide by 3 to tell me that f is equal to 2/3. Okay, that would be not correct. So don't do that. That's all we mean by evaluating a function. And what that means is that when the input is 2, okay, so when you put a 2 in, oh, sorry, I said that backwards. When the input is 3, the output is 2. And that's how that works. So function notation tells you the input and the output at the same time. Be able to use Desmos to identify transformations on absolute value functions. Example, like using f of x is equal to the absolute value of x as the parent function. Remember, the parent function is the simplest function in a group of functions. Describe the transformations. And so what I would expect you to do with that is you would open up Desmos and you would graph the parent function. Okay, something like that. And then you would graph the next function. Okay, and in this case, what you would notice is that the function went right 2 and down 4. Okay, and we are going to study transformations in a lot of detail in this class, but for now, just it's okay to do an exploration, use Desmos, look at the original function, and then look at the new function, and then tell me which way it went. So it went right 2, down 4. Okay, so that's what that one means. Now, there will be a bonus question. The bonus question is going to entail the application of slope. So there will be a bonus question asking you to identify the meaning of slope in an application problem. This will require you to apply the idea that slope is rate of change. Answers will typically be of the form something per something, where the per is the fraction bar from a slope calculation. So if you think about the slope calculation, you have this fraction bar in here. And if you were doing a word problem, you might have 10 miles minus 5 miles over 3 hours minus 2 hours. And so 10 minus 5 is 5 miles over 1 hour. And I want you to notice miles per hour. So you would have like miles per hour. And a lot of times it's written as the fraction bar, but where the fraction bar comes from is from the slope calculation. So answers, typically, if you're asked, what does the slope represent? You would typically give an answer like slope is miles per hour or miles per gallon or feet per second or, I don't know, dollars per day or something like that. So that's typically what the slope would be, and it would come out of the slope calculation, your rise over your run for your inputs and your outputs. All right, last thing, other test info. We will break the test day into a review time and a test time. Okay, so we're going to split the 90-minute class period, unless we get hit with an early release, which occasionally happens, and there's absolutely no way for me to know that right now. But yeah, assuming we don't. We will spend about 30 minutes in review. So we're not going to go over every little thing. That's why it's important for you to be watching this and for you to come with the things that you want to go over. If you don't want to speak up in class, send me an email. Okay, send me an email and say, these are the things I want you to go over. I promise I am not going to call you out or embarrass you or anything like that. I do understand if you don't want to raise your hand. The test will be doable in 30 to 50 minutes. So that's usually what I aim for, is that the fastest students to do the test, it'll take them about 30 minutes. The slowest students will take about 50 minutes, and that allows us for about 5 to 10 minutes to transition between the review and the test. So that allows you some time to put your study guide away, get your calculator out, make sure that your desk is, sometimes we'll separate the desks and stuff. So it takes us a couple minutes to do that. And then you should have 30 to 50 minutes. Typically, students that are done in less than 30 minutes, I'm a little concerned. And if it's taking you longer than 30 minutes, that's also a little bit of a concern. Not all the time, okay? Some students just are going to take a little bit longer. Some people are going to be faster, but generally speaking. Come prepared in advance for which topics you would like to go over. Okay, I just kind of went over that. If you want to review something not on this review, come with specific problems. So if you go digging around, because for example, I told you needed to know horizontal lines, but I didn't give you a problem in the review on horizontal lines. Don't come and show up and say, well, I just want to go over horizontal lines. Say, Ms. Taylor, I want to know what the equation of a horizontal line looks like, or can you go over finding the slope, and here are 2 points, how would I know if the slope is horizontal, or slope is 0? So come with some specific things that you want to go over, like, can you go over this problem from the homework, or can you go over this problem from the lesson? Look in your notes and homework for additional problems. All Unit 1 homework must be turned in by the day of the test. So, like, if you have fallen behind on any of the 4 homework assignments, you can still turn those in, okay, on the day of the test. Late assignments will be penalized. The only exception to that is if you are within a makeup window or an extended time window, okay? Those otherwise, if you're just turning it in late, it will be penalized. After the test, homeworks that are still missing will be backfilled with your in-class test score. Okay, so if you get a 50% on the test, then all of your missing homeworks are going to go in as a 50%, and that is locked in. Like, we don't get another shot at that. And that is true even if you're taking the test with a free retake, which I can explain later what that is, because all of that homework should be turned in already. Okay, so anything is a gift. If you get a 90% on the test, then all your homeworks get filled in at 90. The late penalty will knock it down to a 70%. Okay, so here's the deal. Whether it is better to take the late penalty or the backfill varies by student. So most students are better with the late penalty. Just generally speaking, most of the time it works out better for a student to get the 70% by turning it in late instead of getting the backfill. Now, not all the time. I have had students not do any homework, get like an 85 on the test, and all their homework gets backfilled at an 85. That is the exception. Most of the time, when I am backfilling grades with the unit test score, I am backfilling them with 30% and 40%. It's bad. So the student would have been better off taking the late penalty and getting the 70%. Okay, I'm going to leave that up to you. Like, we all make choices. We want to make good choices. So hopefully you make the best choice. If you don't make the best choice on this test, you make the best choice on the next test. But that is the last little bit of test info. I realize that this is a long video, but it is an entire unit review. So don't complain about it being long. I didn't need to make it, but I did anyway. All right, so come prepared to review, and I will see you then.